Okay, in this video, we're going to look at partial derivatives and specifically interpreting what the partial derivatives mean. So we're going to do cost, revenue, and production formulas. And remember, when we take the first derivative, we're finding the marginal cost or marginal production or marginal revenue. So in this case, again, we have a function of two variables, x and y, and we're going to take the derivative with respect to one of them, which is called a partial derivative. And so we're going to find the marginal partial derivative. And when we take a partial derivative with respect to x and evaluate it at that point, we're going to let our y value remain constant, because that's what we do when we take the derivative. We pretend y is a constant. And we're going to see how the increase in 1 unit of x changes our function. So remember, marginal production means how much is the cost or the revenue or the profit increasing or decreasing when we change from the x to the x plus 1 units. Okay, so when we increase x from x, we're going to be increasing x from x to x plus 1. But then we're leaving y the same, or we're saying it's constant. It's not changing. And when we do a partial derivative with respect to y, it's just the opposite. So again, we'll be evaluating at a point, we're letting our x value remain constant, and seeing the increase in 1 unit of y changes our function. So we're increasing from y to y plus 1, and x stays the same. And then we're seeing what is the impact on our function that we're talking about. So we'll either be talking about production, cost, or revenue. So let's look at a few examples. So a corporation has the following profit function for selling standard and deluxe versions of a product. So this is my profit function. It's in terms of x and y. X is the number of standard versions sold per week. Y is the number of deluxe versions sold per week. And it says find PY of 25, 10, and interpret the results. So we first find the partial with respect to y. When we do that, anything with an x is considered a constant. So the derivative of 140x, that's a constant, would be 0. 200y, okay, y is my variable, so the derivative is 200. Minus 4x squared, again, all x's, so the derivative is 0 because it's a constant. Okay, plus 2xy. So my variable's y. When we take the derivative of y, it's just whatever is in front of it. So it's plus 2x, because again, x is just representing like a number like the 2 is. Minus 12y squared is minus 24y. And then 700 again is a constant, which is plus 0. Okay. You don't have to write out all the zeros. Okay, but that's my partial with respect to y. We are trying to find it at 25, 10. So I'm going to plug 25 in for x and 10 for y and calculate what I get. Okay, and I get $10. Right, so what this means is, okay, again, we're doing with partial with respect to y. So we're increasing our y units from the 10th unit to the 10th plus 1. So it's the number of deluxe versions. So we're going from 10 deluxe versions to 11 deluxe versions. And the number of standard versions is staying the same at 25. And we're saying if that happens, the profit is increasing by $10. Okay, so how we usually write these is we say when holding the production level of standard versions constant, and that's because that's what my X represents. So when we're holding X constant, so increasing the production of deluxe versions from 10 to 11 will increase the profit by $10. So when you're explaining these, you have to say something about keeping the standard level the same. I mean, you could also say when the standard level stays at 25 standard versions per week and the deluxe version sold increases from 10 to 11, the profit increases by 10, that's fine. But you need to talk about the other variable staying constant, the variable we're looking at increasing by 1, and then how much our function, which in this case is profit, is either increasing or decreasing. And if it's positive, it's increasing. If it's negative, it's decreasing. Okay, so let's look at another example. Let's do this one, number 7. So the productivity of an airplane manufacturing company is given approximately by the Cobb-Douglas production function, which is f of xy equals 40x to the 0.03, y to the 0.07. X is the units of labor and y is the units of capital. And it says find fx of xy and fy of xy and interpret. Okay, and this time they're not giving us a point, so we're just interpreting kind of in general what these functions mean. Okay, so for fx, okay, we're treating all of our y's as a constant. So my constant, if I rewrite this and put the x at the end, okay, what I do is when I take the derivative, I leave the constant, or it's called technically a coefficient when it's in front, and then I would multiply by the derivative of x to the 0.03, which is 0.03x, and then I would take 0.03 and subtract 1. Which is x to the negative 0.97, and then I'm going to multiply the 40 by the 0.03. So I would get 1.2. The order doesn't matter if you want to put x or y first, but y to the 0.07, x to the negative 0.97. All right, and then for the interpretation, we would say, do they tell me what x and y represents? Yeah, so x is the units of labor and y is the units of capital. Right. So this function is giving us how much our F function, which is the productivity of the airplane manufacturing, is changing when the units of labor increases from X to X plus 1 and the units of capital are staying the same. And instead of saying like increasing or decreasing, we can also just say the rate of change. Either one is fine. So Okay, so one way to say it would be the rate of change of the productivity. And if you want to be more specific, you could say the productivity of airplane manufacturing when increasing from X to X plus 1 units of labor and holding the units of capital constant. Okay, so that would be my interpretation for the X. Just move that over here. Okay, so then for Fy, I'm going to now consider X as a constant. So I'm going to leave this 40X times 0.03, but then I'm going to multiply by the derivative of the Y to the 0.07. So I'd have 0.07 Y, and then I have 0.07 minus 1. And then just to save a little bit of space, I'm going to multiply the 40 times the 0.07, which is 2.8x to the 0.03, and then I would have Y to the negative 0.93. And I think for this one on the homework, it says you can't have negative exponents, so that means you would have to move this to the denominator, and same with that. But on the exam, you can leave it as an negative. And this is going to be kind of the same interpretation, except we're now changing Y, increasing Y from Y to Y plus 1, and then holding the X constant. Okay, so it would be the rate of change again of the productivity when increasing Y to Y plus 1 units of capital and holding the units of labor X constant. Okay, so then this one says if the company is currently using 1,500 units of labor and 4,500 units of capital, find the marginal productivity of labor and the marginal productivity of capital. So again, Fx is the marginal productivity with respect to X, which is the units of labor. So that's the marginal productivity of labor. We're going to use Fx. And for marginal productivity of capital, that's with respect to Y, and we use Fy. So for the marginal of labor, we would find F, and I'll put the X in a second, Fx of, again, X is labor, so 1,500, and then the capital is 4,500. And so I'm going to plug into my derivative 4,500 for Y and 1,500 for X. And if you calculate that, you should get approximately 1.3. And then for the marginal productivity of capital, we use, again, F of XY, Fy, sorry, of XY. And we're going to plug in 1,500 and 4,500. Right, just to fix, I'm gonna do that one, but this one should be instead. I'm gonna do, I guess, at least 3 decimal places, probably 4, because it's a really small number. .0018 is what it comes out to. I was using the answer on the answer keys, and there's a mistake on the answer key packet for this one. The exponent for both of these is, when they took the derivative, what is incorrect. So just make sure if you're looking at this problem on the packet that you get what we did here. And so then if I plug in this to my calculator, I get 0.0014. And then it says, for the greatest increase in productivity, should the management of the company encourage increased use of labor or increased use of capital? And it's talking about at this point. So we want which one is higher. And so if we look at this, FY is smaller because it's 0.0014 compared to 0.0018. So FY is less than FX, not by a lot, but a tiny bit. And so we want to increase X. So increase the use of labor, which is X. Okay, again, on the answer key for this, there are mistakes for B and C. So just make sure you're referring to this if you're looking at that. So let me know if you have any questions on anything then.